Hello everyone. Thank you for coming back to the channel, guys. And I really appreciate your time coming back here and learning a thing or two. I really hope the videos will keep uploading. You learn a thing or two from every video we upload. Uh, this video will be just about question 2, answering questions on analytical geometry. Okay, I'm told that in the diagram, point A and B, which is in the first quadrant, are points on the quadrilateral ABCD. The equation of line DC is given to be a negative 1 over 3x minus 1. DC forms an angle of theta with the x-axis. Okay. They want me to calculate the size of theta. Please, guys, do not confuse the angle of theta with the angle of inclination, right? The angle of inclination is this guy here, the space between the right hand side of your line and the x-axis. So beta there will be your angle of inclination. So for me to find theta, I must find the angle of inclination first. So how can I find the angle of inclination? I'll simply say beta is equal to 180 degrees minus tan inverse of 1 over 3. Please, guys, remember that whenever we have a negative gradient, we don't substitute negative 1 over 3 there inside the bracket, right? The 180 minus takes care of the negative. So this guy will give me 180 minus the inverse of tan 1 over 3. I get 161.57 degrees, right? So remember that this is beta. But what do I know? I know that theta plus beta, they are angles on a straight line. Are you together? So for me to find theta, I just need to say 180 minus beta. Remember what beta is. Beta is 161.57 degrees. So it simply means that theta is 180 minus the answer we got, then we'll get 18.43 degrees. So theta is just 18.43 degrees. Okay, now we are asked to determine the equation of line AB. If line AB is parallel to line DC, please, guys, remember that parallel lines have the same gradients. Are you together? So and for me to find the equation of the line, I only need two things. I only need the point on that line and the gradient of the line. Are you together? Okay, so I can say that the gradient of line AB is the same as the gradient of line DC, which is what? A negative 1 over 3. This thing is true because I was told that AB and DC are parallel lines. Are we together? So after finding the gradient, and I do have a point there, I can use my equation y minus y1 is equal to mx minus x1, right? So the y1 will be let me write in red. Y1 will be 10, and then x1 will be negative 3, right? My gradient is a negative 1 over 3. So I have y minus 10 is equal to negative 3x plus 3 there. Then y minus 10 will give me negative 1 over 3x minus 1. So y is equal to a negative 3x plus 9. Because whenever I take the 10 to the other side, it will be positive, right? So my equation will be y is equal to a negative 3x plus 9. Okay, now I'm supposed to determine the equation of line AD if AD and DC are perpendicular. if AD and DC are perpendicular. Please note, guys, that if you have perpendicular lines, it simply means that the product of your gradients are -1. I'm told that AD and DC are perpendicular. It simply means that the gradient of AD multiplied by the gradient of DC should be always equal to -1. Remember that I do have the gradient of DC. This is the gradient of DC. For me to find the gradient of AD, I just need to flip the gradient of DC around and then change its sign. So therefore, the gradient of line AD, when I flip 1 over 3, I will have a 3, and then I'll change the sign. The sign of the one gradient was negative, so this one will be positive. I don't need to write the positive sign. So the gradient of line AD is equal to 3, right? So I can simply use the equation, which simply says y minus y1 is equal to mx minus x1. Are we together? So let's go. Y1 is 10, x1 is negative 3. The gradient is a positive 3 like this, né? So I'll have y minus 10 is equal to 3. I'll have x plus 3 there inside the brackets. So y minus 10 is 3x plus 9. Therefore y is equal to 3x plus 19. This will be the equation for the line of AD. Y is equal to 3x plus 19. Okay. D. I'm told that I'm asked to determine the coordinates of D, and hence find the length of AD. How can I find the coordinates of D? D is the point of intersection between line AD and line DC. If I can equate those two lines to find the point of intersection, I can therefore find the coordinates of D. Okay, remember that I just calculated the equation of AD there. So I can simply take that equation. Remember that this is the equation of AD, né? And the equation of DC was given to us as equal to negative 1 over 3x minus 1. I can just equate the two equations and solve x. I can just equate the two equations and solve x. So I'll simply have negative 1 over 3x minus 1 is equal to 3x plus 19. Are we together? For me to solve x, guys, I need to remove the fractions. That means I must multiply everything by 3, since 3 is my LCD. I'll be left with a negative x here, minus 3. I'll have 9x. 19 times 3 is 57. So I'll have 57 there, né? Okay, and then I must group the like terms. That means I must take the 9x to the other side. It will become negative x minus 9x. I'll have negative 10x. Then when I take the negative 3 to the other side, it will change the sign. So I'll have 57 plus 3, which will give me 60. So when I divide both sides by negative 10, I find that x is equal to negative 6. Are we together? So when x is negative 6, I can go back and find the y, the y value. Okay, y is equal to, I can use either one of the equations. I'll get the same y value. So this thing will give me 2 minus 1. So the coordinates of D, I know that x is negative 6 and y is just a positive 1. So the coordinates of D is negative 6 and 1. But the question is not yet done. I was asked to find the length of AD. Where is AD? Okay. The coordinates of A are negative 3 and 10. Okay, let me write them in black. A, -3 and 10. So for me to find the distance of AD, I'll simply say AD is x2 minus x1 squared, y2 minus y1 squared. So this would be a -6 minus a -3 all squared, and then I'll take the y at D minus the y at A all squared. What do I get? Let me just punch here. Yeah, the answer is 3√10. The length of AD is 3√10. Okay, it is further given that the equation of the line BC, it is further given that the equation of the line BC is equal to is x is equal to 6. Show that triangle ABD is isosceles. Where is BC here? Oh, they are basically saying that line BC is a vertical line, né? Because if you are told that the equation of that line x is equal to 6, that means it's a vertical line and x doesn't change. X is always 6. So I'm told that basically they're telling me that the x value at C is 6, and then I have the y value, and the x value at B is 6 as well. I'll have the x value. However, I can find the corresponding y value for B, because I do have the line that passes through points A and B, which is the one that I calculated there, né? So for me to find the corresponding y value for B, I can simply say y is equal to -1/3 times 6 plus 9. So this thing will give me -2 plus 9, which is 7. So the coordinates of B are 6 and 7, right? I'm supposed to show that triangle AD and B are isosceles triangles. So I must just show which two of the sides of this of this triangle, this or this. It seems like I'm showing that they're equal. If I can show that two of these three sides are the same, I can therefore conclude that these triangles are isosceles. Okay, I have the coordinate. I do have the coordinates of A is -10, -3 and 10, right? Coordinates of B is 6 and 7, as I just calculated, and the ones of D, coordinates of D, -6 and 1. I do have the length of AD is equal to 3√10. The length of AD is 3√10. Okay, let me try to find the length of AB and check whether it will give me 3√10. AB is x2 minus x1 plus y2 minus y1. AB. So I'll just take the x value at A minus the one at B and then take the y value at A minus the one at B and see what I get. Calculating today, okay. This is negative 3 minus 6 is negative 9, all squared. It will give me 81 plus negative 10 minus 3 squared will give me 10 minus 7 rather will give me 3. 3 squared is 9, so I'll have the square root of 90 degrees, which is equal to 9 times 10 and 3 root 10. So now I did find out that AB is equal to 3 root 10. Remember that in the previous question I calculated AD to be the same as 3 root 10. So now I can conclude Uti the triangles are isosceles. Why? Because AD is equal to AB. I've just shown that this guy is equal to this guy. So I can simply conclude that the two triangles are isosceles. I hope, guys, the video was fruitful to you, and I really hope that you learned. Thank you for your time, guys. Please stay tuned and stay for more videos. Bye bye.